Hello everyone. So in this video series, we are going to discuss some instrumental methods used for analysis of substances. So whenever we are using any instrumental method for analysis of an analyte, often there is a formation of a cell and we use different types of electrodes for performing that analysis. So here you can see an example of a Daniell cell. A cell can be formed by dipping two electrodes in a solution of electrolyte, and also those electrodes are connected externally. Here you can see that there are two electrodes. One is a zinc metal which is dipped in a solution of zinc sulfate, which is a electrolyte, and there is another electrode which is a copper metal which is dipped in a solution of copper sulfate as a electrolyte. So here, instead of dipping both the metal rods in the same electrolyte, we have dipped them in the separate electrolytes, and then we have connected them internally by using a salt bridge. So this which you can see here, it is a salt bridge. It is used for connecting these half cells internally. So zinc metal dipped in a solution of zinc sulfate is one half cell. Copper metal dipped in a solution of copper sulfate is another half cell, because there is only one electrode in this. So for forming a cell, we need two electrodes. We are calling this half cell because copper metal is dipped in a solution of copper sulfate. It is forming a half cell. So when we connect this two half cells, it is going to form a complete cell. So for formation of a cell, we have connected these two solutions internally, these two half cells internally, with the help of a salt bridge. So salt bridge is used for internal connection of the electrolytes or the half cells, also to maintain the electrical neutrality in the solution. So you can see a salt bridge is filled with a solution of strong electrolyte, which in this case is sodium sulfate. Also, these metals are connected externally. These electrodes are connected externally to form a complete circuit. So this is an example of a Daniell cell. When we dip zinc metal in zinc sulfate solution and we dip copper metal in copper sulfate solution and connect it internally as well as externally, it forms a Daniell cell. So Daniell cell is an example of a galvanic or voltaic cell, and it comes under a type of electrochemical cell. So when we talk about cells, there are two types of cells. One is a electrolytic cell, which I am denoting by E. And here you can see Daniell cell, which is actually a electrochemical cell. So electrochemical cell I am denoting by EC. So these are the two types of cells, electrolytic cell and electrochemical cell. So for formation of cell, we need electrodes, we need electrolyte, and we need to connect those electrodes externally as well as internally. So in Daniell cell, which is an electrochemical cell, you can see here the zinc metal. It is dipped in a solution of zinc sulfate. So this zinc metal, here it is acting as a anode, because here the oxidation of zinc metal is taking place. You can see this is a zinc metal, and here the zinc metal from the electrode is going into the solution as zinc 2 plus. So that means the oxidation of zinc metal is taking place. It is losing electrons which are going in the external circuit. Since it is losing electrons, it is going into the solution as zinc 2 plus ion. So here oxidation of zinc metal is taking place and zinc metal is acting as a anode. So there are two types of electrodes in a cell. One is anode, another is cathode. So if zinc metal is acting as an anode, your oxidation is taking place. Copper metal is acting as a cathode. So the reaction which is going to occur at copper is reduction. So the electrons which are given by zinc metal at anode, the zinc metal passes into the solution as zinc 2 plus ion, and this electrons, they go from the external circuit towards the cathode, which is copper metal. Here the Cu2 plus ions which are there in the electrolyte, it will accept those two electrons and will get deposited on the copper metal as copper solid. So Cu2 plus will accept these two electrons and get deposited here as Cu in solid form. So these are the reactions which are going to happen. So there are two types of electrodes in a cell. One is anode, another is cathode. So in electrochemical cell, anode is negatively charged electrode. So I'll write the electrode sign here. So in both the cases, there would be two electrodes. One is anode, another is cathode. So here I'm writing A for anode and C for cathode. So what is the difference between electrolytic cell and electrochemical cell? In electrochemical cell, as you can see, anode is negatively charged and cathode is positively charged. So I will write the convention. In electrochemical cell, the positive electrode is cathode and the negatively charged electrode is anode, which is opposite in electrolytic cell. In electrolytic cell, anode is positive and cathode is negative electrode. So this is the difference. Another difference between electrolytic and electrochemical cell is that in electrochemical cell, we convert chemical energy of the reaction, of the redox reaction happening here, to electrical energy. As you can see, the bulb is glowing. So here the chemical energy of the redox reaction happening here is converted into electrical energy. So in electrochemical cell, chemical energy is converted to electrical energy. And the word redox reaction means when oxidation and reduction reaction happens simultaneously, such type of reactions are called as redox reaction. So at anode, oxidation is taking place, at cathode, reduction is taking place simultaneously. So in electrochemical cell, chemical energy is converted into electrical energy. So in electrolytic cell, it is opposite, that electrical energy is used to carry out a chemical reaction. That means electrical energy is converted into chemical energy in electrolytic cell. So these are the basic differences between electrolytic cell and electrochemical cell. In electrolytic reaction is going to happen, but non-spontaneous redox reaction is going to happen. And in electrochemical cell, spontaneous redox reaction is going to happen. So this is a Daniell cell whose potential is 1.1 volt. Also, one important thing is the electrolyte. So here zinc metal is dipped in a solution of its own ions, which is zinc sulfate solution. Similarly, copper metal is dipped in a solution of its own ions, which is copper sulfate solution. So in Daniell cells, we take two half cells, but for forming a normal cell, we can dip two metal electrodes in a same electrolyte as well, and we can connect them externally. So what is an electrolyte? Electrolyte is a conducting medium. For this reactions to take place, we need a conducting medium in which these electrodes are dipped. So electrolyte acts as a conducting medium for the reaction to take place. So this is a basic example of a cell. Now let's see how we can represent this cell. So for representation of a cell, this is how we can represent it. Now considering the Daniell cell, we start with the anode on the left hand side. So zinc metal, which is in solid state, is dipped in a solution of zinc sulfate, which is a solution. So in this bracket, you can also write down its concentration. And we have also denoted the sign on the electrode. So zinc is an anode. It is acting as a negatively charged electrode, since we are talking about an electrochemical cell. So we write the metal, the state in which the metal is, it is solid. Then we write the solution in which it is dipped, and in bracket we can mention the concentration also. Plus zinc is directly dipped in the solution of zinc sulfate. So it is denoted by a single vertical line. Then this zinc sulfate solution is in indirect contact with the copper sulfate solution present in the other half cell with the help of a salt bridge. So that indirect contact is denoted with the help of a double vertical line. Now this copper sulfate solution, we can also again write down the concentration of the solution, is in direct contact with the copper metal. So copper metal is its solution, so it is in direct contact. So here in this representation, the direct contact between the metal and the solution, the electrolyte, is denoted by a single vertical line, while the indirect contact between the two electrolytes, which is through salt bridge, is denoted by a double vertical line. Also, we write down the sign which is on the copper metal. It is acting as a cathode, so it is positively charged. And on the right hand side, we write the potential of the cell, the EMF of the cell, which is 1.1 volt for Daniell cell. So this is how we represent the cell. Now also how we can calculate the single electrode potential of a cell. So when we form a cell and we measure the potential, we get the potential of the complete cell. So if we want to find out the potential of a single electrode used in the cell, then we use a Nernst equation, so which we are going to see further. So cell potential, it is actually the sum of the potential of both the half cells. So E standard cell. So E0 cell means E standard cell, which is a standard potential of the cell, which is when we measure the cell potential under standard conditions of temperature and pressure, we get the standard potential of the cell. It is equal to oxidation potential at anode plus reduction potential at cathode. Or if we have to calculate the oxidation potential of the complete cell, it would be oxidation potential of the anode minus oxidation potential of cathode, because oxidation occurs at anode. Or we can calculate the reduction potential of the complete cell. It would be E standard reduction potential of cathode minus E standard reduction potential at anode, because reduction occurs at cathode. So these are the number of ways in which you can represent a cell potential. Now for calculating the potential of a single electrode, this equation is used, which is the Nernst equation. So E cell would be equal to E standard cell, means the potential of the cell measured under standard conditions, minus RT upon NF ln Q. So we know what is E cell. It is the potential of the cell. This is E standard cell, that is the potential of the cell under standard conditions. R is the gas constant, whose value is 8.31 volt coulomb per mole Kelvin. T is the temperature in Kelvin. N is the number of moles of electrons exchanged in the electrochemical cell. So if we consider the Daniell cell, in that case the number of electrons were 2, because zinc was losing 2 electrons to form Zn2 plus ion. Copper 2 plus was gaining 2 electrons to form copper S. So that is N, that is the number of moles of electrons exchanged in the electrochemical cell. F is the Faraday's constant, which is 96500 coulomb per mole. And Q, it is actually reaction quotient. So it is equal to the ln of concentration of the product upon the concentration of the reactant. So this is the Nernst equation, which can be used to when we have to find the potential of a single electrode. So this you will understand further as we will move ahead in the next sessions and see few examples. So that's all for today's session. If you have any doubts or queries, please put it in the comment box. And if you like my videos, please like, share and subscribe. Thank you.